So we've seen that there's a long career path as an academic scientist. How do you succeed? How do you keep getting the postdocs? What do you need to do during this phase to get one of those wonderful long-term jobs? In fact, how do you do science at all? Science is hard. Now, all the research suggests that the thing that really motivates scientists and the thing that advances them in their career is priority. You need to discover something first. And just think a bit about what this actually means. I mean, science is actually a very strange profession because you only get paid to do things that are new. In most professions, let's say you're a doctor, and on your first day in the job you treat a heart patient, and then 40 years later on the last day of your job you treat a heart patient. And all the time in between you might treat hundreds and hundreds of heart patients. So basically you're doing more or less the same thing over and over again, having a patient with heart conditions and helping them stay alive. And that's a great career. You do the same thing continuously. I mean, clearly you need to update your skills as new medicines come along, but by and large you can do the same thing over and over and over again. Likewise, let's say you're a house builder. You can build houses your entire career, and that's a very good career. I'm sure you'd develop new skills as you go on, but if you just keep building house after house after house, that's a good career. You've been a productive member of society. But science is not like this. Let's say you discover something, and then you discover it again, and you discover it again, and you discover it again. No. You only discover anything once. So research has to always be new. Not only can you not discover the same thing over and over again, if anyone else in the world has discovered it, you won't get paid to do it again. You have to do it first. So you're in a competition against every other scientist in the world. And that's different from most careers. Most careers you're not in competition with everybody else in the world, and you can do the same thing over and over again and get rewarded for it. My wife's a primary school teacher. She can teach a primary school class year after year after year, and she'll certainly get better at it with experience, but that's a very valuable and important career. But science is not like that. So you have to do something that no one else in the world has done before, and you have to do it before everybody else, and it has to be significant. I mean, sure, there are lots of things you could research that you might be first in the world because nobody else cares. So there's always a balance when developing a science project between ones that are certainly doable and novel but uninteresting. For example, exactly how many B5 stars are there in the constellation of Orion? Sure, you can do it. No one else has done it before, but then who cares how many B5 stars there are in the constellation of Orion? It's irrelevant. No one cares. You want to pick something that other people care about, maybe because they can use it, like you could find a new laser system that allows communications twice as fast, or you could research how to adapt to climate change, or you can discover what caused the Big Bang, something that's interesting to other people. But if you're doing something that's interesting and valuable, there's going to be more competition. So what are some of the challenges? And the first challenge is that all the easy things in science have been done a long time ago. Second challenge is the vast amount you have to learn before you can get to the cutting edge, because there's a huge literature. And the third problem is there are a lot of extremely smart scientists in the world. How could you possibly do something before every other one of them? So let's think about these in turn. So the first issue, you have to do something new, and the easy things have been done. So Galileo revolutionized science by rolling balls down a plank. Good luck to you trying to do that. I don't know no matter how many balls you roll down a plank, in what way, you're not going to revolutionize the world. Nowadays, to do something comparably influential, it's probably impossible, but the nearest approach would probably involve things like huge teams of people working on giant particle accelerators like the Large Hadron Collider. So, in principle, it almost seems like it makes science impossible. Everything easy has been done. Things are therefore getting harder and harder and harder. Surely this means science will grind to a halt. Well, yes, but first of all, there are constantly more scientists in the world working on these things, and also we have much better tools. I mean, Galileo was trying to discover something fairly easy to discover, laws of gravity and momentum. If you're trying to discover the Higgs boson, it's much, much harder. But also we've got far better tools. We've got Large Hadron Colliders and giant telescopes and supercomputers and things like that. So the only way science can still progress is by using existing knowledge and using all these wonderful new tools. If you're just equipped with the same thing like balls and planks that Galileo had, you will not be able to do science. So traditionalists think we've got to master the old skills, but really The old skills are great for solving the old problems, but you can't get paid to solve the old problems again. The new problems will generally require new techniques. One big change is that science is done in increasingly enormous groups. This is a graph of the number of papers, a number of authors per paper. So a scientific research paper, normally everyone who contributes puts their name on it. The exact details differ from subject area to subject area, but you can see that very few papers in the sciences only have one author. The majority have 5 to 7 authors. So normally you work in teams of about 6 people. But then there's a tail. There are quite a few papers with 10, 15, 20 authors, and increasingly there's a blip up here with papers with often thousands of authors. Here, for example, is the author list for the paper that reported the first discovery of optical counterpart to a gravity wave burst. And so this, of course, required the construction of a number of giant gravity wave detectors and huge numbers of researchers to research how every component in these $100 million exercises were built, plus the people to actually do the optical follow-up and so on. And so you end up with enormous teams of people. So the idea of a lone scientist thinking brilliant thoughts by themselves is pretty much at an end. The next problem is cumulative knowledge. This is the scientific output. This is the number of publications per year. By 1995 there was about 1,000 times 1,000, so about 1 million publications, and it's going up exponentially. This is across all the sciences. And this is a huge problem. Basically, the cumulative volume of knowledge in science is doubling roughly every 10 years. So every 10 years there's twice as much to learn to be at the cutting edge. And how can you possibly do this? One idea would be you just study for longer. So you could think that the PhD would get twice as long every 10 years. I did my PhD in 3 years back in the early 1990s. So that means by the early 2000s it should have taken 6 years. By the early 2010s it should take 12 years. And by now it should take 24 years. Because there's a lot more to learn now than there was back then. This is clearly not feasible. You could easily get to a situation where people spend their entire lives doing 50-year PhDs, leaving them no time to actually do research afterwards. So what could you do? I mean, it's not quite as bad as that, because a lot of the old papers you can just ignore and actually keep up with the current ones. But even so, the number of current ones is growing up, and there are just huge numbers of these things. It's a real problem. There are techniques nowadays like AI paper summarizers that can help you get on top of this enormous mountains of stuff. But the normal solution is by getting narrower and narrower, specializing more and more. So you get scientists like Galileo or Newton or Boyle who would make major breakthroughs in a wide range of different fields: experimental, theoretical, physics, biology, chemistry. By the early 20th century, scientists would now only contribute to one field. They could be a physicist or a biologist, but not both. And in fact, they'd specialize even more than that. Like Einstein would do theoretical physics, but not experimental physics, whereas Millikan would do experimental physics and not theoretical physics. But nonetheless, Einstein would do theoretical physics in gravity and quantum mechanics. By the 1950s, you're much more specialized than that. You'd be a theoretical particle physicist or a theoretical condensed matter physicist. You'd specialize in one particular area. And now it can be even more specialized. People can spend their entire life studying a particular variant of string theory or a particular class of object in space. And that's necessary because of the hugely increasing volume of information to cover. But it's a problem because often the wonderful technique or method that could have revolutionized your work was being practiced in some other field, but you might never find out about it because there's just so many papers to read.